In this lecture, I want to talk about the include statement. And so again, from our first challenge, our first exposure to C code and C program, you should have noticed this include statement. It's on line 8 here in this example, and this is our example challenge project basic C program. You see, it's include, and now because we have learned about the preprocessor, we that is a preprocessor directive because we uh, pound symbol spaces is preprocessor command, a preprocessor directive, and so we know line 8 include special keyword with the pound symbol is a pre-processed directives, and I now want to explain to you what exactly this is doing. What does this mean? Again, this is a basic concept in C that we need to talk about very early on because every C program has it. It's very similar if you are familiar with Java with the import statement. But we are going to describe this in detail now in our slides. But you will see this in all of your C program. So the include statement is a preprocessor directive. Because of that pound symbol, we know that. And we call it a statement as opposed to a directive for no real reason, just because it's common to use that term in programming language. But it is a directive technically. And again, the example in our program was including this something in these angle bracket. So we see this include keyword and then we see this studio.h. And so this is the example. This is the one that we used in our first challenge. It is not strictly part of the executable program. However, the program would not work without it. We know it's a pre-processed directive. It does not really do much as far as how the program works. It's just telling the compiler before it runs, hey, we are doing something here with this include. And so if you don't have it there, the compiler is going to complain and throw errors. So you need it. The pound symbol indicate that it is a pre-processing directives. We talked about that, which is an instruction your compiler to do something before compiling the source code. There are many pre-processing directives, and we gave some examples in our pre-processing lecture. We talked about constants, defined statements. We talked about if and else and so forth, different the conditional pre-processing directives. But this is one of the most really common used ones, the include. And so again, these directives can be anywhere in your source code, but they are usually at the top. In this include, specifically, this include preprocessor directive is very similar to the import statement in Java, if you are familiar with that. But what does that mean? So in the above example here with the include pound symbol stdio.h, this is telling your compiler to include some of your program content of the file that with that name. So there's a file name that exists somewhere called stdio.h, and what the directive is saying is my current program that contains the directives needs some of the content inside this file in order to compile. So specifically, the include directive is going to have file names that end in .h. These are called header files. They are called header files because they are usually included at the top of the source file. It's one of the first things you do is you include all your header files. And again, this preprocessor directive is saying I want some of the content inside that file. It's not a C file. We know that files that end in is .c and C source files. So the .h has to be something else, and it's a header file and it has that .h extension. So let's talk about what a header file is. Header files define information about some of the functions that are provided by that file. And I will give you an example, some of the content in a header file. But first off, they are defining some information about some source code, and specifically for our example with that included stdio.h. This is including a C standard library header. So remember, I told you about libraries. Libraries are just additional functionality that's already written for you and C that you can include in your program. So you don't have to rewrite it. Again, examples of libraries are reading and writing to the console, displaying output, reading and writing files, all sort of different things, doing networking code, many different libraries out there. But stdio.h is a C standard library. What that means is it comes with the C programming language. and it provides functionality for displaying output among many other things. So stdio.h is a header file. It defines some functionality that the compiler needs to understand before it can actually use it. So specifically, stdio.h contains information about printf. And so we are going to talk about printf in the next lecture, which helps us display output. But printf is a function that in the stdio.h header file, and it's also contain many other functionality. Stdio is short for standard input output. So this library is describing it contains functionality for dealing with input and output. And so this is the concept of using a meaningful name. We don't want to call that library JSON or JSON.h because that's not meaningful. We use stdio.h because it's saying standard IO, standard input and output. And we know that library contains all sort of functionality for input alpha, specifically functionality that we want to use in our challenge program. Our example, first program is we want to use this function called printf, which allows us display output to the console. And so by including this stdio.h in our source code, we are saying in order to use this functionality of this printf, we need to include this file. So header files are going to specify information that the compiler uses to integrate and utilize any reuse code, any functions within a program. So you are going to either use many different standard library header files, and there's many out there. Studio.io.h is just one. There is again header files that define functionality or the functions prototypes for networking code, socket code. Again, we are going to go through a lot of them, strings for complete words and things like that. But in addition to the C standard library and the different libraries that comes with the C programming language, you can also create your own header files. And you will be creating your own header files because header files allow for software use. They allow you to reuse functionality written in C. So somewhere the designers of C wrote all the C code that reads and writes data and handles input and output. They don't want this new C programmer to have to write their own. So they are going to write it for you, and they are going to say you can use it. And the way that you use it is you include the header files. And so you, as your own developer, you may write some code in a large program, thousands of files that you want to use in other files. And so you will write your own header files, prototypes, different constants, all sort of different things that are going to help another file that can use your program. It will help compile your program. So it's a software use technique essentially. So we are going to include this standard io.header files in a program whenever we need to use the printf functions from the standard library. It's required. If you don't include it, it will not compile. So whenever you are using certain functionality, you have to use the include. The syntax as far as header files go, they are case sensitive. Case sensitivity means uppercase or lowercase. It matters whether you do one or the other. So you should always write them in lowercase. Your header files should be in a lowercase because otherwise certain systems may interpret them have a different meaning. There's two ways to include header files in a program. You can use a angle bracket such as pound include json.h and angle brackets, and that's this usually means it is telling the preprocessor to look for a file in some kind of system directory. It's usually a standard library that comes with the programming language. You can also use double quotes. Double quotes usually means it is a user-defined header files. It's one that you create as a developer that didn't come with the C program language, but you want to have that header file. So because you want to use some code, so it's also going to say look in the current directory. Every C compiler that conforms to a C level standard will have a set of standard header files supplied with it. These are just header files that represent libraries. C functionality that comes with the language. When you do use the include directive, common practice to use the other preprocessor directive, if not to find and define, so that you don't include the file more than once. This is for efficiency. So if your program is using printf, for example, displaying output to the screen, you want to tell your program, hey, I need to include this additional functionality in the standard library. You don't want to tell it to include it more than one because the preprocessor will do many things that it doesn't need to do. So typically you will see, you will use if not define. So you will see some of this in some of the examples that I provided where I wrap the includes in these if not defines and define statement. Here's an example of a header file in its contents. You may have some header files has some comments in it. It could have other things in it. It mainly has function prototypes in it, but it can have constants. It can have type def. There are some concepts that we don't understand yet, but I'm just trying to illustrate, trying to help you understand that it contains many different things. But again, for our stdio.h, there's something in there called printf that defines the printf function so that when we link, we can find the implementation codes for that. So here are some function prototypes. Function prototypes are just names of functions. We know we know what a function is. Hopefully by now it's just a way of grouping code together. We'll talk about functions in much more detail later. So a header file can include many different things. It can include defined directives, constants, structural declaration. This is again a way to group different variables, group different data. Type def statements have to do with data types. We'll talk more about that, but function prototypes are really the important one. They are telling you how functions are defined so the compiler can generate the code it needs to. Executable code goes in a source code file. Source code file ends in the .c extension. Executable code normally doesn't go in a header file. There are some exceptions when you want to do things in line, which is again an efficiency thing when you can put source code into header files. But typically a .h file header file is not going to contain implementation. It's going to contain lines of code for just a definition. All right. There's not going to be any logic in there. It's just going to be definition. The function exists. That function exists. These constant exist. These different structure exist. They don't say how this code is doing what it's doing. It's just telling you that it's there. It's necessary by the compiler to generate the linking. Okay, so you are going to create your own header files. You are going to use system header files for additional functionality. It's the concept that you need to understand before you move on with writing C programs, because you are going to see this include directive in all programs. And it's just telling the program again that we are including an additional code somewhere. We are including additional definition code so that we can now invoke these different functions in this different code in our C program. So I hope that makes sense. Again, it's not a real complicated concept. We are including additional code. It's pretty intuitive